One other assumption that the exponential model make and the logistic model make that you have to be careful about is that it assumes that all individuals in a population are the same. And for some purposes, you really have to take into account the fact that they aren't. One of the important things, or one of the important ways, sorry, in which individuals in a population are not the same is that they're of different ages. And that may sound really dumb, but let me take you through the consequences of that for population growth. Okay, in a real population, in a real world, individuals are of different ages. And you can have a population that is the same size, in other words, it's got the same number of individuals in it. But if you have more young people or fewer young people in that population, it's really going to change how it behaves. So let's look at these three examples here. Over here, you've got a population. It's got males and females. Let's say there's a human population, right? It's got males and females, and there are a lot of really young individuals in this population. A fair number of the individuals are between, say, the ages of 15 and 44. They're in the kind of the middle range here. But there are very few individuals that are older than, say, 44, 45. Over here, you've got a totally different scenario. You've got the same number of individuals, but very few of them are young. Most of them are, in fact, quite old, over 45 years old. Why does this matter? Well, in this population over here, most of the individuals have not yet started to reproduce. They're going to. They're going to quite soon, within, say, they're going to start, all of them are starting to reproducing within, say, 15 years. There are a very large number of individuals in this population that are currently able to reproduce, and so they are going to be generating a lot of new individuals in the population. Hardly anybody in this population over here is beyond reproductive age. Okay, in contrast, over here, you've got a relatively small number of individuals that are going to be making new babies. Most of the population is beyond the baby-making age, and so most of them don't really count as far as population growth is concerned. Okay, these different age structure profiles are found essentially in different kinds of countries. Some countries are undergoing rapid population growth. These are often developing countries where health standards have increased suddenly and mortality has dropped very sharply in a relatively recent time span. So countries like Guatemala, Nigeria, Saudi Arabia, they're all experiencing very rapid growth. A number of Western industrial countries are going through what's called zero growth. There are enough babies being born to these individuals of this age that they're replacing the individuals that are dying of old age, but no more than that. And there are actually a few countries now that are undergoing negative population growth. There are so many elderly people in the population that they're actually dying off at a rate that's faster than they're being replaced. Okay, so this is the key thing you need to realize about age structure. Old individuals are not the same as young individuals. In particular, a population with mostly young people will grow very rapidly, while a population with mostly older people will stay the same size or even decline. We're going to revisit this point when we talk about human population growth in a few weeks.